vast majority of the world's political leaders have concluded that our future is going to take a serious turn for the worse unless we take immediate action. But first, let me say what I'm not going to tell you. Okay, so I'm not going to tell you what to believe. And I'm not going to tell you what's right or wrong. You have your own values you use to make those determinations. I will tell you about the scientific evidence that documents we have a big problem. And in so doing, I'm going to ask that you listen to the skeptics, the real skeptics, the scientists, because objective skepticism is the heart of the scientific method. The oldest scientific society in the world, the Royal Society, founded in 1662, has as its motto, don't take anybody's word for it. Now, our problem, we can think of it in three questions. Must we change, can we change, and will we change? To understand why the answer to this question is yes, we need to start with this guy. Fourier was a contemporary of Thomas Jefferson's. He marched with Napoleon, and he was a physicist studying heat. And Fourier is the first one to realize that the Earth's atmosphere acts like a blanket, keeping it warmer than it otherwise would be. This is now a principle of physics we know as the greenhouse effect. The Earth gets almost all of its energy from the sun. Most of the sun's rays pass through the atmosphere, striking the planet and warming it up. And just like anything else that warms up, a car seat in the sun, a frying pan on the stove, the Earth begins to radiate heat in the form of infrared radiation. Now, most of that radiation escapes into outer space. But because there's a layer of heat-trapping gases in the atmosphere, those gases absorb some of that outgoing radiation and send it back down to the surface. And that extra energy is why the Earth has the temperature that it does. Mars has a very thin atmosphere, a very weak greenhouse effect. It's a very cold place. Venus has a very thick atmosphere, a very powerful greenhouse effect, and has a surface temperature close to that of molten lead. And the pattern you see is not because of the relative positions of the planets compared to the sun, because Mercury, which of course is the closest planet to the sun, has a thin atmosphere, a very weak greenhouse effect, and has an average surface temperature well below that of Venus. Now, over the last 250, 300 years, humans have been adding prodigious amounts of these heat-trapping gases to the atmosphere, mainly by burning coal, oil, and natural gas, and by chopping down forests. And this has had the effect of thickening that layer of heat-trapping gases. So now energy that used to escape into outer space is captured by the atmosphere and re-radiated back down to the surface. And it's that extra energy that is forcing our climate to change. Now, Fourier postulates this in the 1820s. In 1859, Irish physicist John Tyndall demonstrates in the laboratory that, in fact, there are component gases of the atmosphere that can absorb heat. So this is the chemical mechanism underlying Fourier's hypothesis. And in 1896, Swedish chemist Svante Arrhenius combines these concepts mathematically into the theory of global warming. Here's the first page of his paper. Arrhenius calculated what the temperature of the Earth would be if we doubled the amount of carbon dioxide in the atmosphere. And he got very close to the answer we get today, and he did it with a piece of paper and a pencil, which shows how basic the physical principles are that underlie our crisis. Now, when Arrhenius started making these calculations, the amount of human emissions, as evidenced by that red line, had really just gotten underway, but they really took off during World War II. In 1965, President Johnson was warned by his scientific advisory panel about this problem, but he didn't do anything about it. He did speak about it publicly. Now, the science was clear at that time, and it's not just government scientists, right? The fossil fuel industry knew as well. Here's a quote from one of Exxon's scientists. And this is the source of that hashtag Exxon knew. Now, in 1978, the Department of Defense told President Carter that, hey, this was going to be a big national security problem. President Carter asked our National Academy of Sciences to double check the work of the Department of Defense. And our National Academy concluded, and they told the president there is no reason to doubt the climate changes will result, and there is no reason to believe these changes will be negligible. Now, President Carter was an engineer, right? And he said, hey, wait a minute. So he put solar panels on the White House, and he set as a goal for the nation to get 20% of its electricity from new renewable sources by the year 2000. Now, that would have been a really good idea, but we didn't do that. Instead, we elected Ronald Reagan president. Ronald Reagan couldn't care about these issues. He took the solar panels off the White House, and emissions really took off. Now, also at this time, and even continuing today, there's an organized campaign to deceive the American people and their political leaders about the serious nature of this problem. And so you had ads like this from Mobil Oil, when of course we know that their scientists were telling them that wasn't true. Now in 1988, senior NASA scientist Jim Hansen testified before Congress, and he said that greenhouse warming was almost certainly underway. And it helped that this was a really, really hot day in June. And this really got people's attention. It led to the global treaty in Rio in 1992, which started the Conference of the Parties that continue today. It initiated the Intergovernmental Panel on Climate Change. And to this day, Dr. Hansen remains a global leader in the effort to educate people about climate science and the need to reduce human emissions of greenhouse gases. Now, I wanted to take a minute to look at what Dr. Hansen told Congress, because that work was later fraudulently misrepresented to Congress. And we can see both how well we understood the problem in the 1980s and how so many Americans have been deceived. Okay, so what Jim Hansen did was he had a model of the average of the Earth's temperature, and he was able to project that into the future by looking at solar energy coming in and energy being radiated away from the planet, and then also to look at the greenhouse effect. And the big uncertainty for Hansen was how much carbon dioxide would be in the atmosphere in the future. So he created three scenarios. Okay, the first scenario was if we just went gangbusters, continuing to burn fossil fuels and accelerating our use of fossil fuels, and temperatures climbed like this. Now, there was also a more moderate scenario in which temperatures didn't rise quite as much because we slowly reduced our use of fossil fuels, but we're still adding carbon dioxide to the atmosphere. And then there was a scenario in which we stopped putting carbon dioxide into the atmosphere, and you can see that the temperature of the Earth responds. Now, when we look at what's actually happened, and that's what this red line is, you can see we're pretty much on track with scenario B. Now, there was this active effort by people to deceive the public. One of the favorite things they tried to do is get this narrative going that scientists are alarmists and that Hansen is wrong. And this reached its peak with the testimony of the Cato Institute's Patrick Michaels before Congress. And what Michaels did was that Michaels took Hansen's work that you can see here on the screen, and he represented it just with scenario A, which was that high emissions scenario. Then he put temperatures to that point on the screen, and he said, look, oh my goodness, there is this huge difference between what was projected and what's actually happening. Okay, and here's the actual graph that Michael showed Congress. But of course, he was not showing the full story. He purposely left off the lower emission scenarios. When you put those back on the screen, you of course see that we're very close to scenario B, right? But the idea here was to deliver a narrative by falsifying Hansen's work. And that narrative is that scientists are hyping worst cases, they're fear mongers. And not only is that myth supported by fabrications, as we can see here, but it's also just plain wrong. Science is actually a conservative enterprise where claims of knowledge are greeted with organized, objective skepticism. Remember the motto of the Royal Society, right? Don't take anybody's word for it. There are three ways that science is really a conservative enterprise. First is the standard of proof that scientists use. We're all acquainted with different kinds of standards of proof, like more likely than not, or beyond a reasonable doubt. Scientists use the chances I'm right are at least 20 to 1. And this is, in the language of statistics, this is the 95th confidence limit, right? And scientific historian Naomi Oreskes points out that this statistical convention essentially represents a value judgment. The value it reflects is that the worst mistake a scientist can make is to think an effect is real when it's not. You can think of it of wanting to be sure you're not being gullible, you're not fooling yourself, you don't have undue faith in your own ideas, right? And so it's really like scientists play dumb on purpose, right, with this approach. Now, what this means is scientists is prone to what's called a type 2 error, where you're taking this conservative approach and you miss causes and effects that are actually happening, right? So, and that adds risk to our as we think about climate change, because if we're wrong, then the consequences are really enormous if we don't pay attention to the problem. Now, the other two ways that science is a conservative enterprise is that scientists are reticent to be seen as speculating or alarmist. The vast majority of scientists don't speak in the public at all, and if they do, they speak in probabilities, not certainties. And even if their conclusions are alarming, they won't use alarmist language. Hansen has suggested that there's a culture of what he calls scientific reticence, that scientists are reticent to conclude and communicate scenarios that would be disturbing to employers, funders, governments, and the public. In addition, the third point is that scientists tend not to project what they can't yet model. And so for climate change, that means we know that there's some big tipping points out there where climate could start changing very fast. For example, the great ice sheets could start falling apart, and sea level could rise faster than we think. So these are the kind of things that lead, these three things, to the idea that the scientific culture and convention leads to underestimating future risk, not overestimating it. And now we're seeing with our own eyes and instruments that what Arrhenius and Hansen and others predicted is coming true. The Earth is getting hotter. Okay, there are 5 independent data sets. They all show the same thing. This heating is not uniform across the planet. There's more heating in the Arctic than in the temperate regions. This pattern called Arctic amplification, this was predicted in the 1970s by the Department of Defense and the National Academy of Sciences when they reported to President Carter. Now, some people might say, humans are really adaptable, right? So if the average temperature of the Earth goes up a couple degrees, can't we handle it? And one way to understand that we really have never faced such a challenge is to look at the temperatures that have been in existence on the planet during the time that human civilization has evolved. That's about the last 10,000 years. And if we look at it, this is what we see. In fact, the temperature went up about 1 degree Fahrenheit over about 5,000 years, and then it went down again for the next 5,000, except right at the end here, when you can see that the climate has changed. And it's gone up over 1 degree Fahrenheit in just 200 years. And if we don't have an immediate and sustained effort to change the way we generate and use energy, then this is where temperatures are going to go by 2100. Now, there's some debate about whether the temperature rise will be 8 degrees Fahrenheit or 6 degrees Fahrenheit, but there's no debate about the direction of the change, right? If you put the kettle on the stove and you turn the heat up under the kettle, the water doesn't start cooling down on its own, right? But how far up we go, this graph is up to us, but we're already committed to going part of the way up for sure. And that's because we have altered the atmosphere in an extraordinary way that the Earth has not seen in over 800,000 years. And we know this from data from ice cores. And I'm going to show you this graph now on the next slide. We're going from right to left. We're going back in time. And you can see where we are today. And you can see the blue line is the carbon dioxide. The white line is the temperature. And you can see that carbon dioxide is at concentrations we haven't seen in the last 800,000 years, going up 200 times faster than any other time in this record. And this is the source of the urgency in the scientific message, because carbon dioxide stays in the atmosphere for a long time. So all the time the carbon dioxide is there, it's absorbing energy that would otherwise have gone into outer space and sending it back down to the planet. And if we keep dumping carbon dioxide into the atmosphere, this is where we're going to be in just 30 or 40 years. And This is like wrapping ourselves in so many blankets that civilization will not survive as we know it today. Now, some people might say, wait, well, how do we know that this isn't some kind of natural phenomenon that has nothing to do with us? That's a really great question. Scientists have been investigating that question for decades. The easiest way I've come to think about it is to recognize the Earth is a huge thing. And so if you're going to change its temperature, you have to have an enormously powerful source of energy. Well, the only thing that's powerful is the sun, or energy that's derived directly from the sun. Now, if the Earth were to get closer to the sun, that would heat the planet up. And the Earth's orbit is not stable, right? It oscillates between being more and less elliptical. When it's more elliptical, the planet spends more time further away from the sun and ice accumulates on the planet. That's one of the drivers of the ice ages. But those changes happen on the scale of 40 to 100,000 years. So that can't explain what we're seeing in the last 10 years or the last several decades. So another thing could be if the sun just got hotter, the Earth would get hotter. And the sun's output does vary, and it varies on the scale of decades. So maybe this is an explanation, except we can measure the sun's output very carefully now with satellites. And when we do that, we find out that the output of the sun has actually been in decline over the last several decades. And the variations themselves are not enough to explain the change in temperature we are observing. Right? If we put these natural factors into a model and look, say, at ocean temperature, here's the kind of data that we get. Now, those big dips are big volcanic eruptions because they will put dust in the atmosphere. It will stay for a couple of years and cool the planet down, but it settles out. Now, then when we put into the model the carbon dioxide concentrations that we're measuring in the atmosphere, the model says, well, no, because of the physics of the greenhouse effect, temperature should be in this green range. Well, now we have a hypothesis we can test because we can measure the temperature of the ocean. And when we do that, this is what we see. The key point here is that there is no way to explain what we are observing except for the impact of greenhouse gases. And for you fans of logic out there, there's no explanation for why greenhouse gases are not causing this. That's a different question. And this is why the US Supreme Court held in 2007 that the US EPA had to regulate greenhouse gases as a threat to public health and safety pursuant to the Clean Air Act, because there's no other explanation for what is happening. Just as was predicted, the Earth's cryosphere, the big ice collections of ice on the planet, are disappearing. Okay, I'm going to show you a video of the Arctic ice cap. Okay, starting in 1984 and going to 2016, you'll see also this graph that will show you that the thick old ice is disappearing and we just have thin young ice replacing it. So here we go, and you'll see as each year goes by, the ice cap tends to get smaller and smaller and smaller, and the thickness of the ice cap gets smaller as well. So this is happening in 3 dimensions, right? Just as was predicted. Okay, here we are, 1984. Here we are, 2016. I got to see this firsthand because in the summer of 2019, I stood where that red dot is. Okay, this is what it looked like. You can see that the wind has blown icebergs into the shore, but there is no ice visible on the horizon. My guide told me that if we'd been there 25 years ago, we could have walked out onto the pack ice. We're also seeing ice loss in Antarctica that is accelerating as well. Now, climate, right, is the envelope in which everything happens, all of our natural systems and all of human enterprise. And when we disrupt the climate, we can disrupt everything. And climate disruption is going to affect the availability of water, the productivity of farms and forests and fisheries. These 2 changes are going to make it more difficult to feed people in the world. We're already seeing the availability of water change in California, as was predicted decades ago. What has been predicted is that as snow level rises, we're going to get more winter precipitation coming down as rain instead of snow. That runs off immediately, and that means that the snowmelt pulse, which we capture in our dams in the spring, and we use that in the summer and the fall, that pulse is going to be a smaller percentage of the overall flow of California's rivers. And that's exactly what the state of California is finding here in the Sacramento, our largest river. We're going to see increases in the prevalence of oppressive heat and humidity. Here's just a picture of what's going to happen in Santa Rosa. But remember, even though it's going to get hot, we still get to determine how hot. If we have an immediate and sustained effort to change the way we generate and use energy, if we transition away from fossil fuels, this is what Santa Rosa can look like at the end of the century. We're going to see an increase in the concentration of air pollutants, both from forest fire smoke, but also because photochemical smog is a temperature-dependent process. We're going to see a change in the geography of disease. The entire idea of tropical diseases, that reflects the fact that the creatures that pass those diseases between humans live in the tropics, but no more. Like this guy, the Asian tiger mosquito, Aedes aegypti, is now well established in North America. This is the creature that transfers Zika, dengue, yellow fever, and chikungunya between people. We're going to see damages from storms and droughts and wildfires. This is becoming dreadfully obvious now to everybody. We're going to see property loss from sea level rise and coastal erosion. This is going to be a huge problem in the San Francisco Bay Area where I live. And we're seeing a change in the distribution and abundance of species. Global populations of fish and birds and mammals and amphibians and reptiles and insects, they're all in enormous decline. And this reflects the fact that the ecosystems that support them are being disrupted. And these are the same ecosystems, of course, that support us. Now, when we look at the rising seas, we can already see that it's begun. At Fort Point at the Golden Gate is the oldest tide gauge in the country. And we can see that the global average sea level as measured at Fort Point has risen by about 7 or 8 inches since 1900, but almost half of that has been since the early 90s. In the future, this is what we're going to see happen. The red and the blue line each have their own uncertainty range around them. The difference between the red and the blue line, again, just like with Jim Hansen, it's how much carbon dioxide we put into the atmosphere, right? We can slow sea level, but sea level is going to be going up no matter what. These are actually curves, and sea level rise will be accelerating all through this century as the great ice sheets try and come into equilibrium with the heat we've already put into the planet. Now, there's another possibility for sea level rise, which I'm going to put on the graph now, and it's this. Now, this is there not because it's plausible, but because it's possible, right? This is if the great ice sheets were to break apart very quickly, and there's some evidence that this might be happening, then we could get a much quicker rise of sea level. Regardless of how fast it goes up, we can already see our future if we go out at the king tides, at the highest tides of the year. And when we do that, we can see that what a normal high tide will be looking like in the future. In the Bay Area, we have lots of transportation infrastructure that is built very close to sea level. It's already beginning to flood. Climate change is going to bring higher wave heights, and along with the higher sea level, that's going to generate more coastal erosion. And this building that's been abandoned in Pacifica is just a sort of iconic image, but this is happening all over the world at coastlines. Another big challenge we have to face is that warm air holds more moisture. This is something that you can demonstrate in the laboratory. And so when it rains and there's warmer air, there's the chance for major downpours. And we're seeing this all over the country and indeed all over the world. Meteorologists are calling these rain bombs. And you'll just notice if you pay attention now to the news every so often, a month of rain came down in one morning, right? Just last month, it was in Nashville. And Nashville had another major flood right in 2010. And then this month, it's been in Indonesia. If the precipitation comes down as hail, like it did in Guadalajara, it can be absolutely free. It can just, pardon the pun, but freeze the town until it melts. Fire season is now getting more and more intense. Fire season is longer. The fires are very, very hot and behave in different ways, making it very difficult to fight them. And they're burning larger and larger areas. Over 4 million acres burned in California in 2020. That was twice the previous maximum. And the fires can impact people far from the flames, as California residents are learning. It was bad in 2017. It was even worse in 2020. This is now a regular feature of living in California, and you might want to go buy your N95 mask to be ready for the fall. But despite all these impacts, the changes that keep me up at night are the political cascades of events that can ensue if people don't have food, water, or shelter, and they have to move. R. James Woolsey and colleagues, the ex-director of the CIA, they produced a study in 2007, and this is what they concluded. Profoundly disquieting. We all have to decide what that means to us. I wasn't sure until I saw this picture. I found this picture profoundly disquieting. And this is with only tens of thousands of people on the move. Imagine when it gets to be millions. And that's what's projected for the middle of this century. So must we change? To go back to our three questions, I think the answer is clearly yes. Can we change? All I can say is I'm glad the answer to this question is yes as well. Humanity already possesses the fundamental scientific, technical, and industrial know-how to solve the problem. We don't need to wait for new discoveries. We have everything we need to begin right now. I'm going to give you a sample of the basic solution with 5 major components, but there are other components that other analysts might put in there. The basic picture looks like this. So this rising graph is our emissions if we don't change our tune, if we just keep burning fossil fuels. We want to go this way and get down close to zero by the middle of the century. So that means there's this whole triangle of emissions we have to forego. So how do we deal with this big amount of emissions? Well, we need to think about it in slices. I'm going to show you 5 key slices that will help us undergo the transition that we need to. First is energy efficiency. Just the idea that we can get the services we need, the energy services we need, without using as much fossil fuels, or even just as much energy wherever it comes from. California has shown that how we can become more efficient, right? This blue line is the electricity used per capita in the 49 other states of the Union. And this green line is what's happened in California. And that's because in the early 80s, we adopted energy efficient building codes, energy efficient appliance standards, and we changed our regulatory structure to allow our utilities to make money by helping us use less energy. In the past, they can only make money by if we bought more kilowatts. And so that was an incentive that needed to be changed. In addition, we're now going to have new technologies as well that are going to come online that are going to help us become more efficient, like LED lights. They were a novelty 10 years ago, but they're going to be taking over the lighting market because they use 1/10 the electricity. They last much, much longer. As Amory Lovins likes to say, saving energy costs less than buying it. And that is a key incentive that we need to unleash in order to become more efficient. The next slice is to think about electrifying transportation. Now we've started, right? There were, in February of 2021, the sales of electric vehicles were up 138% over February of 2020. But the problem is that fully electric cars were only 2.3% of total US sales. It was a little higher in Europe and about 8% in China. And we have to transition to completely electric fleet of vehicles. Now, one thing that's going to help us do that is that battery prices are falling and that there's a booming market for cars that do not produce emissions, just for air pollution improvements in addition to climate change. And as a consequence, auto manufacturers are moving to electric vehicles. And General Motors has said that their fleet will have zero emissions by 2035. Now, the proof is in the pudding here for GM, in my opinion. But we're also can see now how we can start to think about electrifying entire sectors of our transportation sectors, like buses. New buses in California will have to be electric by 2029. There's enormous number of electric buses already in China. And we're going to see long-haul trucking be able to transfer to electricity as well. The third piece here is to generate electricity without using fossil fuels. This is something that we have the technology to do. And these technologies, which once commanded a premium price, are now dropping to near parity with fossil fuels. So onshore wind costs have declined, offshore wind costs have declined, and the cost of solar cells has plummeted as well. This has allowed actual solar capacity to just explode beyond what was projected in the last decade here by the International Energy Agency. And it means that solar cells are popping up in places you might not expect them, like the Kentucky Coal Mining Museum, which put a solar array on its roof to reduce its energy costs. Large solar parks in China and in India are now producing electricity for less than the price of coal plants. And solar is also expanding in the developing world, where there's the opportunity to pay as you go using your cell phone. And these cell phone transactions are actually allowing people in very remote places to be able to pay for the price of solar. The fourth slice here is what we can call natural carbon solutions. The basic idea here is that carbon is part of an ecological cycle. There's only so much carbon on the atmosphere, on the planet, and it's constantly changing form. Sometimes it's in the atmosphere, sometimes it's in the soil. So that means that ecosystems can be part of the solution. I'm going to show you a picture here, just of a generic picture of this cycle. Carbon dioxide in the atmosphere, it's pulled into plants. The plants decay into the soil. Sometimes those are taken up by animals. Some of it becomes fossil fuels, and we dig up the fossil fuels and we burn it. And we're greatly accelerating the right side here. So we need to accelerate the uptake of carbon by our working lands. We can do this with our farms and our ranches and our forests. And when we do this, it can be a real win-win for farmers. I'm going to show you a picture here of the same land with different management. On the left, you have what's known as regenerative agriculture, where there's no-till operations underway. The farmers are planting cover crops in the winter, and the soil is much richer, and that richness includes carbon taken from the atmosphere. Those soils also drain much better, and during the great flooding of the Missouri River in 2019, on the left is a farm using regenerative agricultural techniques. That soil drained and allowed the farmer to plant, whereas on the right, the soil didn't drain and the farmer couldn't plant, and those were the farmers who suffered the most because of the flood. The last piece is a price on carbon. The idea here is that we live in a market economy, and markets only allocate goods and services efficiently when the price in the market reflects the cost of production. But as any beginning student in economics learns, there are things that we call external costs, because the market is not perfect. And so there are costs that are external to the market, so they're not reflected in the price. And so people tend to use more of those goods and services, and these external costs accumulate. That includes health impacts from the burning of fossil fuels, and it also, of course, includes climate change. In addition, subsidies affect the market. And right now, we subsidize fossil fuels way more than we subsidize renewables. And we need to flip this around, because right now we're subsidizing our way into getting more of what we don't want and less of what we want. But when we put all of these slices together, and there's several others, you can see that we have addressed that big triangle of emissions. But the longer we delay, the harder the job becomes, right? We have to go this way. But if we climb, then we have to literally sort of jump off an economic cliff to get to where we need to get to. You know, if we had listened to President Carter, we could have had a much more gradual path to climb, but that's no longer available to us. Now, in California, our economy is growing as we are reducing carbon emissions, although this is only a down payment on the kinds of reductions that we need. But it was exciting to see that California met its 2020 goal to reduce greenhouse gas emissions to 1990 levels 4 years early. And these renewable technologies, there are a lot of jobs and they can't be outsourced, right? Wind turbine technician and solar panel installer, these are the fastest growing jobs in the United States, according to the Bureau of Labor Statistics. And it's going to stay that way for several years. The message from the economists is very, very straightforward. The most expensive thing we can do is nothing. The costs that will accrue if we do not get ourselves off of fossil fuels are enormous compared to the investment we need to make now. And the same thing is true then for the Green New Deal. We've heard people say we can't afford the Green New Deal, but a true economic analysis concludes that we can't afford not to do something like it. So what is the answer if it's not something of that scale? The answer is that there is no answer. We need to act at scale now in order to address the problem, but we can do it. We can change. The question, the third question, as you recall, is will we change? And while we are changing, the real question now is, are we going to change fast enough? Because currently we're not. One of the ways we can really see this change is what's happening with the use of coal in the generation of electricity. And we have some surprising partners in this, like the president of Appalachian Power, West Virginia's largest utility, one of our proudest coal states, right? And this is what he told his Republican governor in 2017. We're seeing a lot of plants that had been proposed were already defeated. We've had many retirements, and there are many more proposed retirements and retirements that have been announced. So this entire industry is in essence being canceled before our eyes. I was struck by this quote from the president of the CEO of Next Era Energy. There's not a regulated coal plant in this country that is economic today. Most of these plants are still being operated because of the regulatory environment in which they can that allows them to pass costs on to customers. But they're still closing down. The latest casualty was Unit 4 of the Scherer plant in Georgia. This is the largest coal-fired power plant in North America. It has 4 units, each producing almost 1,000 megawatts, and Unit 4 is going to close down. One of the major owners of that unit, the municipal utility of Jacksonville, Florida, said the decision to close will lower operating costs and substantially reduce operating risks. In Indiana, another one of our proud coal states, the Northern Indiana Public Service Company has said it's going to close all of its coal plants by 2028 and transition to wind power. And this is going to save their customers enormous amounts of money. And so we can see the change in US coal consumption. And for the first time, we can see that last year, renewable energy produced more electricity than coal in the United States. We also have a situation where every country on the planet has got together and recognized we have a common problem we have to deal with. And all of us can be the change as well. In fact, we have to be the change that we want to see. We can influence our own carbon footprints, how much carbon is put in the atmosphere by our activities, particularly in California, through our transportation and our food choices, right? Do you have to drive? Can you walk? Can you ride a bike? Can you carpool? When it comes time to acquire a car, think about getting a high efficiency car or an electric vehicle. I've got an electric car and they're fantastic. If you haven't driven one and you're in the market for a car, please go check one out. Our food choices also have a lot of carbon embedded in them, and particularly beef has a much higher carbon footprint than chicken or certainly than vegetables. Now, if you have vegan friends, you already know this, right? And I'm not saying everybody on the planet has to be a vegan, but we can reduce our carbon footprint by eating less meat for sure. We also can conserve energy and water. One of the largest uses of electricity in California is the pumps that move water around the state. If you have a utility contract, you can probably purchase renewable power directly. There are alternatives like the East Bay Community Energy here in the Bay Area, or Sonoma Clean Power. In your community, if you are a utility customer, you can probably access through your existing utility the various renewable power plans that then allow you to help drive the market for renewable power. This is happening in the global world, in the corporate world on a global basis. We're seeing enormous interest in these major corporations that use huge amounts of power to have clean energy driving their company's operations. So we also need to be politically active. And this, I know this is at the heart of what a lot of you are doing this week. That's fantastic. This is not a Democratic or Republican. We all need to be doing this. And if you are a Republican and you think about the values that have drawn you to the Republican Party, and then think about the science I've just shared with you and figure out how we can take action on this scientific problem that is consistent with your values, and then talk to your candidates, talk to your elected representatives about that, and vote for candidates who understand this crisis, right? And talk about it. I think probably many of you are already familiar with a lot of these issues. We cannot let this problem be a taboo around the dinner table. We all have to learn how to talk about this, talk with our crazy uncle at Thanksgiving. People are beginning to speak up, which is very, very exciting. And remember, this is happening all over the world. John McCain really got it right when he said that global warming presents a test of foresight, of political courage, and the unselfish concern that one generation owes to the next. And for sure, the young people in the world are speaking up. And I think a lot of you are probably in the generation more of my children than of me, and I'm encouraging you, talk to the older people in your life and help them recognize that you understand that your future is getting squeezed by what we're doing today. I think that that young people can be incredibly influential with their elders, as we can see here from this quote from Greta Thunberg. Remember, be kind, but be forceful, because we have to change now. The climate change that's going to happen in the next 20 years has already been decided by the emissions we've put into the atmosphere. Those emissions are going to absorb energy that would otherwise have gone out of outer space. That's going to drive climate change. The question is whether we take action today so that 40, 50, 60 years from now, things are different. That is the question of our time, and it is your action and your commitment that is going to determine how that question is answered. I hope you will all consider the words of Apollo astronaut Rusty Schweickart. He said, "We're not passengers on spaceship Earth, we're the crew, we're not residents of the planet, we're citizens." And the difference in both cases is responsibility. Thank you so much for your attention, and I'll be happy to answer questions.
Thank you so much, Andy. That was fantastic. We'll give people a chance to put any questions they might have into the chat or comments for Andy. This is a really incredible presentation, very clear arguments and fair-minded openness too. So really, thank you so much for bringing all of this forth, and you just cover so much.
My pleasure.
Yeah, just really, really crystal clear. I want to ask you, Andy, has anything changed in the way you see this problem in the last 12 months? And I don't mean politically necessarily, although that's important and very important that we have this new administration, but in terms of scientifically, is there something new that's coming out to you a little bit more in the foreground?
Well, I mean, there are a lot of things that are happening. Some of them are very exciting. In particular, the change in the price of renewable energy is just extraordinary. I mean, I think it was the International Energy Agency that in 2020 basically said, oops, we're going to have to change our projections because solar energy is actually 50% less expensive than we thought. And so that is driving a tremendous amount of activity. And I think people are waking up. Certainly, as I go around, I've given talks like this. I talk to Rotary clubs, I talk to a lot of people, and people are much more aware. And I think it's also because of, activities like tUrn. This is why I wanted to come back this year, right? People are aware that this really is the work of nations. We don't have a choice. We just have to do this. And I'm excited to see that in the American Jobs Plan that President Biden has introduced, that there's a tremendous focus on the fact that all the investments we make from here on out, these investments have to be part of transitioning us away from carbon. And these investments go all through our economy. It's really, really essential. But the flip side is that we still see evidence that we are not changing fast enough. Methane concentrations are rising in the atmosphere. Carbon dioxide concentrations continue to rise in the atmosphere. There is a lot of momentum behind the burning of fossil fuels, particularly in China and in India, although there's been a big shift in India recently in terms of the projection for future coal plant construction. So I think that we really need to make sure that we don't despair here. that I really like what Christina Figueres, who was the chair for many years of the UN climate program, who said that we need to be stubborn optimists, right? We need to talk about it. We need to focus on it. We need to do the work, but that's the only way that we're going to really bring this transition into being that we need to have. So I'm hopeful. The problem is still very serious, but I think we're seeing more and more people rise to the occasion and recognize how serious it is, and just adopt an attitude that says, well, we just have to do this. And so that's what we're going to do.
I like that.
Awesome. And we also just got a new question in the chat that says, can you say something about how to consider human population growth rates and policies in respect to this challenge?
Yeah, that's a good question. I mean, at the heart of that is the idea that if we have fewer footprints, then our carbon footprint is lower. Now, that is true, except when you look at the world, you end up concluding that this isn't a problem of population, it's a problem of consumption. So we still have the situation where the vast majority of the carbon in the atmosphere has been put there by relatively small number of humans. And if you look at people's current use of carbon fuels, in fact, it's way higher in the United States, say a factor of 5 to even factor of 10 higher than in the developing world. And even in the US, there's this huge disparity. There's a growing recognition that we have sort of 1%ers, right, on the economic scale. Well, we also have 1%ers on the carbon scale, right? People who are doing all the flying and who have a huge a carbon footprint. And in fact, if we put a price on carbon, and then we just took that money that was raised by, say, a carbon fee or a carbon tax, and we send it back per capita to everybody in the country. So your refund would be per capita, but you would pay based on how much you used. 70% of the country would make money on the deal, right? So I think that we do eventually need to get human population under control, but the most important ways to do that, and I think you guys have heard from Project Drawdown, right? The empowerment of women around the world is one of the best and most important ways to bring human population under control. But we should not forget that it is people in the United States like us who are the ones that are doing most of the consuming and most of the emitting.
Great. And then I also just got a message directly that says, how can we persuade others to minimize the meat within their diets, especially in America?
Well, that is an interesting question. I think that one of the important things about putting a price on carbon, in my opinion, is that, you know, it touches everything then in the economy that is carbon intensive. So it will drive up the price of beef. Now, it's hard to get people to do what they absolutely don't want to do. But it's worth, you know, if you're in this situation, it's worth talking about it. You know, it's worth making people recognize that if you can eat just a little less meat, the problem won't be as severe. Or we can begin to focus on having people try an Impossible Burger or try some of these meat substitutes that are coming out. There are a lot of people who think that the meat problem is going to be solved in the next 20 years because the price, the quality of these plant-based or lab-based meats are going to be so good, and they'll be so much cheaper that people will gravitate towards those products. But I'm not sure right now whether it's, you know, I don't think it's worth pushing people. If someone eats a lot of meat, well, maybe it'd be better to try and get them to buy an electric car. But it's important to acknowledge that these are real problems. And you know, if we're just in conflict with each other, then we're not going to, I think, make the kind of progress that we need. But for each of us, we can make our own decision. One of the things I always tell people, if you haven't taken some of these steps, you should do it and see how you feel, right? When I first put a solar system on my house, I was worried about the price. And a friend of mine who's a solar installer was saying, how come it is that people ask me all the time, when is your solar system going to pay for itself? But they don't say that they don't ask about the payback for granite countertops. And that's really true. And people put granite countertops in their kitchens because they really like it. And he's told me, don't worry about the price. You're one of these guys who, as soon as your solar system's installed, you're going to stand in your driveway and you're going to watch your electric meter spin backwards when it's really sunny. And he was absolutely right. That's exactly what I did. And so whatever steps we can take, eating less meat, reducing our transportation energy use, being politically active, these things will help feed our own hearts. And that's going to build. And if someone can't quite get there on meat, but they're really aggressive with transportation, well, they're doing their part. That's how I would approach it. Because if we just browbeat people to change their habits, I think that we're going to struggle.
Definitely. And I just saw this one gives a little bit of context beforehand. It says different parts of the country have different problems related to climate change. For example, Oregon has plenty of water but cannot easily switch to solar power, whereas California has a lack of water but plenty of solar energy. How significantly should we invest in infrastructure to share resources with parts of the country experiencing different problems? For example, building aqueducts to divert water to dry places.
Yeah, diverting water from one place to another means that somebody has less of it. And I don't think that's going to be very popular. I once gave a talk out in Walnut Creek, and a guy came up to me and he said, you know, this was really pretty interesting. I thought this didn't really amount to much, but you know, my son's been telling me, just like some of the things you said, that we should be thinking about this in our business. And I said, oh, what's your business? And he said, well, we grow rice in the Sacramento River watershed. And rice, of course, is a very water intensive crop. And he says, I don't understand why we can't just build a pipeline from Washington and bring down some of their extra water. And I said to him, well, you know, I think the folks in Washington would say, why don't you come up here and grow rice? That's what they would say. We see that same tension with the Great Lakes region, right? The Great Lakes region has lots of water, and Texas wants to build pipelines to bring water to Texas. And the same thing with Arizona. And the folks in the Great Lakes are saying, no, I think we'll keep it here. Why don't you come here and live here? And so I think that there is the water issue is going to be something that those who want to live in places where there is less water are going to have to get used to it. We're certainly going to see in California this year, we're going to have a very low water year. But remember, 80% of our water is still used by agriculture. And so that's where most of the cuts will have to be. But with regards to sharing electricity, that is a really, really important thing. Right now, we really have three major grids in the United States, in the East, in the West, and in Texas. And we need to build more connections between these so that when the sun is shining in Colorado, we can be sending excess electricity that we generate to Chicago. And when it's windy in Chicago, we can be sending those electrons to Colorado if it's cloudy. The same thing in California and Oregon. I mean, we've been doing that for years in California. We have been using the electricity, the extra electricity that has been generated by the big federal dams on the Columbia River in Washington through the Pacific Intertie. So we need to really advance those connections in order to be able to use electricity, share electricity between different parts of the country as different sources are producing. So I think that's a very important step. But I think for the water, we're going to be much more likely to need to figure out how to use the water that we have more efficiently than we are to be able to grab water from other places.
I think that's fantastic. I have that graphic up if you want me to show it, Andy. If you want to stop share for just a second, I could show the graph of the population study that you were citing earlier.
Sure.
It might be nice to see that visual. If I can find it here. Yeah. Just, we had a speaker on campus last week come.
Okay, this is pretty good.
Isn't this lovely? It's maybe not the best shot because I think I grabbed a screenshot of her talk, but this was with the SCU ENACT, Students for Environmental Justice, and their guest speaker came and spoke about how the poorest 50% of the world, if the bottom to top is world population arranged by income, getting higher at the top, richest at the top, the poorest 50% are responsible for only 10% of the total lifestyle consumption emissions. And if you look at this, giant, what do you call that, martini glass shaped curve, the richest 10% are, using huge amounts. And so when we talk about overpopulation, I think you did such a great job of answering this question already. I'm not trying to re-answer it, but I just want to emphasize for the audience that this is really one of the ways that people in the developed world, particularly very privileged people, come at the climate crisis with this question of, oh, if only overpopulation wasn't a thing. And really, we caused the problem of the climate crisis, and now we have a problem wondering how we're going to feed everybody. But it's not that there's not enough food, it's that we're eating too high on the food chain. And it's not that there isn't, enough. There's problems with some distribution of that, but really, it's our duty as people in the developed world that have consumed far more than one Earth's worth of things and are on the road to doing more of that. It's really up to us to consume less. And so, anyways, I just like to share that just to make sure.
Yeah, thanks for sharing that.
Justice.
That's really, that's a great visualization of the problem.
Yeah, yeah. All right, so we're going to wrap up soon. We'll be here on for a couple more minutes if anybody would like to hang out, but I just want to thank our speaker so much.